Hello everyone, this is Xinye Bai. This video is recorded for my Lab 2 homework for CSE 564. Lab 2 this lab implements fundamental data clustering and dimensionality reduction. The datasets used in this experiment is from a Chicago public house sales dataset. This dataset is an information-rich dataset which includes 1,460 sample points with 51 dimensions. The Python API Flask is used to preprocess these datasets, which provides for the conversion of numerical variables to categorical variables, replacing non-values, and sampling. Includes the random sample and stratified sample. At the same time, in order to ensure the efficiency of HTML operation, all calculation parts are completed through Flask library, including training k-means, and calculating of the eigenvalue and eigenvectors, and calculation of covariance matrix, PCA dimensionality reduction, and MDS dimensionality reduction. So the final effect displayed on the web page is a total of 6 plots from top to bottom, like here. And we can see those datasets, those figure with 3 datasets is set 3 buttons nearby the figure. When clicking on the button, color of the button will change so that highlight which dataset you are selecting, like here. All figures in the page initially set to plot the original dataset. So let's see the figures step one by one. The first one shows how to select the elbow at the cluster number using the k-means algorithm. So here, the optimized cluster number is 14. The second figure shows the intrinsic dimensionality of the dataset selected based on the scree plot. So we can see the intrinsic dimensionality of original dataset is 88. For the random sample dataset is 58, and for the stratified sample dataset is 57. The threshold is chosen by the number of PCA, which can explain the 75% of the cumulative variance. And the next one it shows how to get top 3 attributes with highest PCA loading. So we can see the top 3 attributes for original dataset is garage type, central area, and type of the house. The 3 attributes for random sample dataset is type of the house, year, the house rebuilding, reconstruction, and the basement finished type. And the 3 attributes for stratified sample data is type of the house, overall condition of the house, and the type of the foundation. And the next figure shows 2D scatter plot mapped by top 2 PCA vectors. We can see this is for the original dataset, and this is for the random sample dataset, which is not very similar to the original one. But we can see the stratified sample dataset looks very similar to original one, and we can see the stratified sample method works well. Every cluster is left in this figure, and also we keep away those outliers like this one. And the next one shows the scatter plot matrix generated by top 3 highest PCA this one shows the 2D scatter plot mapped from MDS. Here we have two more button, because we calculate MDS according to Euclidean distance and the correlation distance by the similar distance and dissimilar distance. So let's say the dissimilar distance first. And this is for original dataset. This is for random dataset. This is for stratified dataset. Let's see similar distance for MDS. This is for the original dataset. This is for the random dataset. This is for the stratified dataset. Okay, next one, the last one is shows the scatter plot matrix generated by top 3 highest PCA loaded attributes. We can see this is for the original dataset. This is for the random sample dataset, and this is for the stratified sample dataset. So also the stratified sample method looks like more similar with the original one. The difference between 3 specific datasets can be obtained by comparing the PCA loaded attributes and also the scatter, also the scatter plot matrix, and the PCA plots. We can say stratified sample methods is actually more similar with the original dataset, and the sampling method can actually keep away the outliers. That's it. Thank you.